Welcome everyone to our Dairy Food Safety Office Hours. I'm your moderator, Sam Alkin, Associate Professor in the Department of Food Science. And right now the temperature is getting cooler. Nutritious leaves are beginning to fall and lay on the floor. There's a daily cycle of light moisture. Kind of reminds me of the conditions for Listeria. Coincidence? Not when you've got Dr. Martin Wiedmann, the Gellert Family Professor of Food Safety, on the call. Just yesterday we had a recall of mushrooms for Listeria. And earlier this fall and the summer, we've seen Listeria recalls in both ice cream and cheese. And now the thing is, Listeria is not like those ghosts that are about to be coming up right at the end of the month. You're actually going to find Listeria in your facility from time to time. And the important thing is what you do about it. How do you figure out where it's coming from and then ensure that you've addressed the cause so Listeria doesn't wind up in the dairy foods you make? So Dr. Wiedmann is going to give us a primer on how to handle root cause analysis in our facilities, and then we'll open it up for questions for a panel of experts. So I'll pass it over to Dr. Wiedmann. Take it away.
Great, thanks, Sam. So I'm not just going to talk about how to get rid of it, but I'm also going to talk about why we continue to see it as an issue. So as Sam mentioned, so this is taken straight from the CDC page, Listeria continues to be an issue. And these are just highlighted outbreaks from the CDC webpage. If you go to their webpage, I went there yesterday, this is what you see. And probably to the dismay of many people in the dairy industry, dairy products still show up almost every year in this list. In 2023, it was ice cream. 2022, it was cheese and ice cream. 2021, it was queso fresco. And these are just the highlighted outbreaks. There were other outbreaks in these years that are linked to dairy products. So the question does become is why, Listeria, can say, started in the dairy industry, the infamous 1985 outbreak linked to pasteurized milk in California. Here it is, almost 40 years later, and we're still battling this. Why is this? Why can we not get this under their control? And I'm going to dig into that a little bit because hopefully it will help us figure out how to better control and further reduce listeriosis cases linked to dairy products. So here are my top 10 reasons, and I'm not going to read through them right now, but I'm going to go through them sort of one by one, or sometimes two at a time, to sort of give you an idea of why we're still here, why we're still challenged by this pathogen. So I'm going to start with the first two topics and then bullets, and those are going to be very, very important, particularly bullet number 2. So as a reminder, Listeria monocytogenes, I'm just talking about monocytogenes, the pathogen here, is a very common organism. We have done a large number of studies where we look outside food processing plants, even outside farms, and we can find Listeria monocytogenes to be very, very common. We found it with more than 7% of samples we took from urban sites. We, in a recent study, found in about 8% of samples, when we collected samples from natural areas, so these were national parks, state parks, regional parks throughout the US. We went north, south, east, west, looked for Listeria, about monocytogenes, about 8% positive. If we talk about Listeria species, which is what we often test for in dairy plants, we find typically 30% prevalence. So that means in these same national state parks, 30% of soil samples, water samples we take positive for Listeria species. So to a certain extent, this is obviously scary because it means we have continuously a high risk of introducing Listeria and Listeria monocytogenes in a dairy plant. But it also, I think, is important to keep in mind because if we find a single positive every now and then, it cannot and should not be interpreted as the end of the world. We expect this with this higher frequency. And this is one of the reasons why we always talk about environmental monitoring programs in dairy plants. You expect it to find it because we have an organism that is so frequent, okay? Now, the other reason why Listeria is going to continue to be an issue is linked to how we detect Listeria outbreaks. And we all know that over the last 10 years or longer, we have started to use whole genome sequencing to detect Listeria outbreaks. And the impact of this is shown in this graph, which is taken from a CDC paper. And maybe the most striking one is the one on the very right side, where we see the number of Listeria cases linked to a specific food source, which went from an average of 13 to 20 a year to more than 100 a year with whole genome sequencing. What else happened is we find more outbreaks, 2 to 5 to 9. And this is going to be important, and we're going to focus on this a little bit more. We find more smaller outbreaks where we might only have 2 or 3 people that got listeriosis, but we can still link it to a food source. Now I'm going to drill into that last part a little bit deeper by, taking a look at the bluebell outbreak. And what you see here, these are the cases of the bluebell outbreak and what's called the bluebell outbreak. And what we can see is this is an outbreak where the cases occurred over 5 years. There's like 1 case in January 2010, a couple in 2011, 1 in 2012, and nothing in 2013, cases in 2014. What we're seeing now and what we're going to see in the future, and this is some unpublished work that we are doing right now, is this is going to get even sparser. I predict, and I'm pretty sure on this, we will start to see outbreaks where we may only have 2 cases 8 to 10 years apart. So we will see outbreaks where we might have a Listeria case in 2010, Listeria case in 2024. They're both in the same county. And then we may or may not have a matching isolate from a small processing facility, maybe even a farm, maybe a deli. I don't know what it is. It's going to be different, but we're going to have these extremely small outbreaks that occurred over a long time frame, and we will see more and more of those. And some of those will be traced back to dairy. That is where we'll be looking in the future. So we need to be aware of that this increase in the number of outbreaks linked to products will change as we accumulate WGS data over much longer time frames and as we accumulate more WGS data on isolates from processing facilities. And so this is why this is not just not going to go away, but why it's potentially going to even get more challenging and worse. And we've seen some precursors of that in some of the more recent outbreaks. Okay, so the next 2 issues why we're going to continue to see Listeria issues is that Listeria growth may be enhanced in some foods as our food system changes. And even if products doesn't support L monogrowth, we might see use of these products in a way that transforms a product where Listeria doesn't grow and therefore is unlikely to cause human disease cases to a product where Listeria grows. So let's look into that a little bit more. So, and these are really lessons learned over the last decades, okay? So if we had a number of outbreaks linked to products that we traditionally considered relatively safe, not absolutely, relatively safe, or maybe better say relatively low risk, such as ice cream and frozen vegetables. But what we saw there is in some of these cases, these products may be used in smoothies, they may be used in ingredients, once they've been used as ingredients in a product, that product may have been stored at refrigeration temperatures where it can allow growth. As a non-dairy example, traditionally people thought, apples don't support growth, but we had an outbreak linked to caramel apples, where the fact that they were coated with caramel and the fact that a little wooden stick was stuck into them and could have introduced Listeria into the center of that apple really created a product that did support growth of Listeria monocytogenes in these products. So the key learnings from this is, in the past, I think we would say, is our product likely to cause an outbreak of listeriosis? I think right now, for many products, we need to ask ourselves, we need to assume any product can cause a listeriosis outbreak. We just need to say, what would have to happen to our product that we consider relatively safe for it to be linked to an outbreak? Yeah, and I'm going to throw this out without any outbreak on the horizon, but we can say, let's look at some of these extremely hard cheeses. And these hard cheeses don't cause outbreaks. Listeria doesn't grow. They probably even die off slowly in these products if you have post-pasteurization contamination. But what if they become ingredients in certain different products where the water activity goes up, the pH goes up, and the product might now be allowed for growth. So we really need to think about consumer use and how that impacts the likelihood of different products causing outbreaks or causing cases. let's talk about, the susceptible populations. And I think I'm not going to have a specific slides for them, but we all know intuitively and otherwise, and COVID has already taught us this, is that immunocompromised populations, people that are more likely to get listeriosis if they ingest a food that contains Listeria monocytogenes increase. So even if we make some improvements, some reductions in Listeria contamination of different foods and dairy products, at the same time, if the number of immunocompromised people that ingest our foods go up, could be a zero-sum game. We make the product somewhat safer, but people require less Listeria in a given serving to get sick, and therefore the total number of cases, the total number of outbreaks will stay about the same. So it's not, we can't just expect by making food safer or reducing Listeria contamination that immediately means fewer cases and fewer outbreaks. Next bullet is one of the reasons why we will see continued cases is that the issue isn't just in processing plants. And this becomes an interesting and challenging question for the dairy industry, because we need to ask ourselves very critically, how far does our, I'm going to say, responsibility continue as our products are handled throughout the supply chain, whether it's in retails, whether it's in hospital kitchen, whether it's in restaurant kitchen, etc. And I'm going to bring an example there, a couple examples of that indicates the importance of that. We've quite a while ago done quite a bit of work on Listeria in retail operations. At that time, this focused on delis, so places where deli meats are cut, but very often these are the very same places where cheeses are cut and sliced and displayed. And we found a striking number of positives for Listeria monocytogenes, as well as evidence of Listeria monocytogenes persistence in these retail establishments, including maybe the most sort of concerning issue of pretty high prevalence of Listeria monocytogenes on food contact surface. And what we're talking about here is Listeria monocytogenes positive, not Listeria species, 4.5% of food contact surface samples positive. So that means some of our products that may leave a dairy processing plant without Listeria contamination may become contaminated at retail. Now, this is not just theoretical. Many of you may have seen this. So this is a relatively recent small outbreak that was detected in the state of Washington, which was linked to contaminated milkshakes, but the most likely source were the ice cream machines and the milkshake and the equipment used at the restaurant level, okay? But it caused 6 cases of listeriosis, including 3 people who died, apparently. So what is the responsibility of the dairy industry to make sure we work with these end users of our products to make sure that we don't get recontamination through different means? At the end of the day, this will show up in any high-level CDC list as an outbreak linked to dairy products. So something we need to critically think about as we look in the future of food safety and trying to continue to drive down the number of listeriosis cases and outbreaks that can be linked to dairy. Reason number 7. It can be very difficult to find Listeria and know whether you have a Listeria problem in a facility. And this is a slide some of you may have seen before. This is based on some work we've done with a number, and we've published this work with 7 cheese processors. And they all had routine Listeria environmental monitoring programs. And this is Listeria species prevalence now. And we trained them to do these programs. And what you can see here, if you just look at overall prevalence across zones 2, 3, and 4, we have a wide range. We have the facility F, which is like in the books, looks picture perfect, no positives out of 334 samples. And then we have the facilities that look like they have a major issue, 23% of samples positives, 24 out of 106. Now, we all know very well that it is very, very difficult to compare prevalences between facilities. We don't necessarily know is this what the contribution is in terms of how many are zone 2, 3, and 4 samples. Did they collect samples selectively to pick dry, clean looking surfaces? Did the people who collected samples really work hard in finding positives, and so on? Or were some people just simply not trained well enough how to find Listeria? And one reason, of course, will be, how hard did people look like when they went into their facility to collect Listeria samples? Did their knees, did their pants look like this? Did they come up with the crispy, clean white pants and lab coats they went in, suggesting they didn't really look hard enough for those sites where Listeria and Listeria monocytogenes might persist? And so what we did in this study to address this is we sent what we call expert samplers, so people that were independent from the facilities in these facilities, and did what I kind of call here a non-regulatory swabathon. So for those of you not familiar with this concept, a swabathon is the idea of someone from the outside, and in the US typically is referred to the FDA, coming in and collecting a lot of swabs to try to find Listeria. And often these are not swabs, it's called a swabathon, but it's really sponges. So maybe better to call it a spongeathon. Okay. And so what you see here and what I color coded for you is the findings from us, and this was people from our group at Cornell going in relative to the routine prevalence were actually striking. And these are patterns that we've since been able to repeat in other types of facilities, produce and otherwise. So in 3 facilities, we actually found substantially lower prevalence of fewer percent positives as compared to the routine sampling plan. Okay. In a few facilities, and the best example of that is probably facility E, we found about the same prevalence the facility found. And then we have 2 of them where we found substantially higher prevalence as compared to the routine sampling plan, including that facility that had no positives, where we found 3 positives out of 50 samples when we went in there once. So that sort of suggests something very, very important. It suggests that the routine environmental sampling programs implemented in facilities fall into really what I would call 3 categories. The green category, which are the people that are essentially doing things right, okay? They're finding Listeria, and remember the routine prevalence over 1 year, and they seem to be taking actions to reduce the Listeria prevalence over time, okay? Because after a year of them finding on average 5.1% positives, we only found 1.3% positives. So these ones, if you look at, one term that's often thrown around with Listeria is seek and destroy. If you look at seek and destroy, they are pretty good at seeking it and finding Listeria, and they're pretty good at destroying the Listeria, or more accurately, destroying the places and changing the places where Listeria could survive. Then you have the facility that seem to be pretty good at the seek part, they find it. Facility E is sort of the stereotype for that. But they don't seem to have much of a grasp on how to reduce it. And this will go back to our later point about root cause analysis. These will be the facilities probably not very good at root cause analysis or don't do any root cause analysis. And then there are the ones in red, which we would characterize, or could potentially characterize as those that are neither good at seek nor good at destroy. And often they can't be good at destroy, they don't even know where to go, right? They don't even look hard enough. They sample the wrong sites, they use the wrong sampling methods, might use swabs instead of sponges. They might, pick the sites to be super clean. They might sample right after sanitation, maybe even on surfaces they already have sanitizer on, and so on, and so on, okay? And so this really sort of illustrates, particularly if you look at the black and the red ones, why in some facilities we will continue to have Listeria issues. As long as we don't move everyone into that green area, probably even with lower Listeria numbers than this, we will continue to see issues. And these are some of the issues. Again, some of you may have seen this slide, but it illustrates a point very well. If I'm given a sample site in a facility, which looks like this, some people might sample on the diamond board, maybe even right after cleaning and sanitation. Not very likely to find Listeria, particularly if it's dry. Some people might sample on the tiles here, on the dairy tiles here, might be more likely to find something, particularly if the caulking is cracked and represents a possible niche. If you sample on that interface between the dairy tiles and the diamond board right here, and you stand on a diamond board where your weight now take some of the water, some of the liquid that's under it, which is exactly what happened in this case, comes out and can be picked up via sponge, you're even a lot more likely to find Listeria, and therefore identify this area as an issue. So the nuances, the details of where to sample and how to pick your sample sites are extremely important for you to find Listeria and then eliminate and control it. So this brings us to the next 2 points, which is even if we find it, control and elimination of sources is difficult and expensive. And finally, some of you may say we get into the actual point of root cause analysis procedures and how they're often not well defined, not well developed, and often completely lacking, which means we are not getting the benefit from our environmental monitoring programs, and we're not reducing the Listeria risks in dairy products in these facilities. So RCA, abbreviation for root cause analysis. So my point here is that root cause analysis and continuous improvement strategies are key to reduce the risk of Listeria recalls and outbreaks, as well as food safety issues in general. Okay. And if you're working in food safety or food safety and quality, if you actually develop strong root cause analysis capabilities, and I've seen this in some companies, people will actually use your strategies in other areas that don't have anything to do with food safety and quality. It might be reduced productivity to address other issues. So good root cause analysis capabilities have broad benefits for a company. What is important, and one of the key take-home messages for today, is that root cause analysis and formal use of root cause analysis tools, and I'm going to talk about this some more, need to be incorporated into food safety programs, and it needs to drive short-term as well as long-term improvements. And if this is not enough, FDA requires good root cause analysis. If they ever find an issue with a pathogen in your facility and your root cause analysis isn't up to their snuff, the time it takes you to open your facility, time it takes you until you get FDA off your back will be longer, and you will have more problems. And you don't want to develop these root cause analysis capabilities when you have an issue. You want to develop and practice them before you have an issue. So here's what you sometimes will read about root cause analysis. And to me, this actually illustrates some of the key challenges. So this is a person I don't know in this blog, right? What does FDA want when you perform a root cause analysis? And they propose that the answer is simple. They want you to find the real fixable root cause of problems and then fix them so they don't happen again. And I think many of you might maybe look at it saying, yeah, this makes perfect sense. I don't know what Martin finds wrong with this. What I find wrong with this is that it implies that every root cause analysis will find a cause that is fixable and can be fixed right now. The reality is a good root cause analysis will often point you to complicated, complex root causes that I can't fix tomorrow or in a week, that require long-term commitment to fix them. Think of, as an example, food safety culture. If your root cause analysis point at food safety culture, now it's not enough to just hire another person and give them a fancy title such as Chief Food Safety Officer. It is a long-term challenge to address that and improve your food safety culture. What does that mean? Very often when people do root cause analysis, they're afraid to get to the true root cause because they're afraid they can't fix it quickly enough. And it's not a simple fix. And I think this is one of the key things that is really hampering root cause analysis and use of good root cause analysis. And we got to get beyond that. Now, that also requires outreach and work with FDA and regulatory agencies so they don't have unrealistic expectations. Understand that. Okay. So here's an example, and it's a non-dairy example, but I think it's a good one. It's from an FDA, I think it's from 483. And this was some food safety issue related to uncooked fish, and root cause analysis that the company provided that said the primary cause was restaurants serving raw or uncooked fish. Well, that's not really the root cause. They go further that the root cause was contamination from wood pallets and poor sanitation practices due to SOPs not performed in an adequate manner. Now, if you use a 5 why for your root cause analysis, this is probably why number 2, right? Why weren't the wood pallets sanitized? Well, because we have poor sanitation SOPs. FDA typically is not going to be happy with this because they're like, all right, your next question really should be, why did you not have good SOPs? Or why are your SOPs not being followed? And then continue down that road, which is then going to lead you to a root cause analysis where you're not, in this case, just going to redo your SOP for your wood pallets and not just going to retrain people how to clean wood pallets, but all of a sudden you're going to realize we really need to look at all our SOPs, sanitation SOPs, or maybe even all food safety related SOPs. And we probably have to revisit in general how we do training. How can it be that we have people that are not trained properly? And it moves beyond the very specific cause, a specific piece of equipment not being cleaned properly. If your root cause analysis typically stops at that very specific level, well, people didn't follow the SOP for equipment X, my ice cream filler for argument's sake. And so therefore I'm going to retrain them on the ice cream filler, but I'm not going to look at my pasteurized milk holding tanks. I'm not going to look at my other fillers. I'm not going to look at all of the food safety related SOPs. Your root cause analysis is not asking enough whys. So we need to change that. And we need to realize that sometimes these fixes will take longer than a few days. It is very tempting to say, well, our problem and the root cause is SOPs for the wood pallets because I can retrain these people in about a day and I can fix that SOP in about a half a day, okay? But if I say our problem is much more systemic, that takes longer, okay? But we need to go there to really, truly long-term drive continuous improvement. Okay. We also need to acknowledge that sometimes root cause analysis can't find a real root cause, and this could be a single, not so much in an outbreak, but if you have a recall where you have a finished product positive, that single finished product positive can just be a fluke, okay? Now, that might be less likely in dairy, but if you think about raw produce, you harvest a large field, a random bird flies over, contaminates one head of lettuce, that can and does happen. Similar scenarios can happen in the dairy industry, right? So if you have this, if you really did a good root cause analysis, you have a good, strong procedure, I think you can still close out your root cause analysis, but you need to document the process. You need to document that you had a large number of possible root causes. You need to document that you eliminated them. And, what I call, and this is somewhat joking, but somewhat not, is, when in doubt, very often, and one of the underlying the true root causes that you might not have, your food safety culture might not be quite up to snuff. People are cutting some corners potentially, etc. And honestly, my feeling is FDA very often looks at least food safety culture and the lack of certain components of food safety culture being part of the root cause analysis. Here's some tools. I'm not going to dig into deeply into that, but one of my recommendations, how to drive continuous improvement is to have a formal root cause analysis procedure. Have an SOP. As part of that SOP, have agreed upon procedures and tools, okay? Say, all right, we are using a fishbone diagram and 5 why analysis. Here's how we're going to do this. For our root cause analysis, you need to have at least 3 people. They need to at least represent the following parts of our organization. They need to represent sanitation, maintenance, and food safety and quality, and maybe production. Maybe it's 4, but you need to write it down, okay? You need to train people in root cause analysis. It needs to be documented who they are. You need to have a very strong procedure. One take-home message from this one, for those of you either in industry or training people, make sure your company or the companies you're working with have written root cause analysis procedures and have clearly agreed upon tools they will use. When you have a recall, when you have an outbreak, is not the time to think about where you're going to find a fishbone diagram that you're going to use and whether you should use 5 why or fishbone or both of them combined. That's the stuff you need to figure out before the issue. Okay, here's an example, and we did this for the produce industry, where we came up with sort of an example fishbone diagram. If you have a Listeria issue where you find the same Listeria subtype more than twice, here's what you're gonna go through in your fishbone diagram. It provides structure, okay? What are some examples of the type of long-term changes that need to be driven by environmental sampling and root cause analysis? Yeah, retraining can't be all of it, all right? Rewriting an SOP can't be all of it, but very often improved sanitation procedures and improved SSOPs, improved preventive maintenance programs, improved sanitary equipment design, and in the long term, even improved sanitary plant design and some of the infrastructure investments should come out of good root cause analysis. Okay. Obviously, and I think for many of the parts, but particularly for bullet 7, 8, 9, training is obviously very, very important. And we all know, and it's really, this COVID sort of come really very much more problematic than even before. It's like turnover in the industry and turnover of experienced staff, a continued focus on training in food safety and training in very specifically Listeria control is important. Listeria is still, and for a long time coming, hopefully convinced you of this, going to be one of the major business risks in the dairy industry because the outbreaks are high impact. 20% of people with listeriosis die. There are population groups that people simply are not willing to accept, such as to get sick, such as pregnant women having abortions because of Listeria. We need to continue to focus on this in the dairy industry and beyond. Okay, this is not just the dairy industry, but the dairy industry is high up on the list of products and that cause listeriosis. And in the past, we in the dairy industry, and I'm going to include myself here, often argue, well, it's raw milk, Jesus. It isn't just. And I think some of the recent outbreaks that I illustrate show that. Okay. I'm going to give you a bonus, number 11. I think this is a very important reason why we continue to see Listeria issues, that our Listeria control programs are not validated and verified. Often we just do some environmental monitoring to sort of verify our sanitation, but I'm going to go back to the key definitions of validation and verification. In my book, validation determines that a given procedure can effectively control Listeria in my facility. Of course, first we think pasteurization, and we have the PMO, we have other documentation, is that, pasteurization at the required time temperature combination, yeah, absolutely gives us a substantial reduction in Listeria that reduces the risk to essentially nil. Particularly if combined with high quality raw milk, okay? Verification then just determines that these validated procedures are consistently implemented. Now, we often, typically don't have the same strengths of validation and verification for control strategies such as cleaning and sanitation, okay? We do a couple of ATP tests, we have a couple of little swabs, swab a small set of surfaces, say, yeah, people sanitized. We might have some titration logs that, yeah, we use the right concentration. Yes, we have the right temperature of our CIP. These are all verification procedures. These are not validation procedures. Most of the plans I go in, they verify sanitation, but they don't know that the procedures really can effectively control Listeria. This is a large topic for another time, and we have workshops where we cover this, and if someone is interested, they can ask us how you can learn about this, but I'm going to give you the Cliff Note version of this. To me, a validation of sanitation procedures, a validation of an SSOP would involve having your equipment, doing your standardized cleaning and sanitation, make sure the SSOP is being followed, assemble the equipment, do normal startup, don't run product, completely tear apart this piece of equipment as much as you can. No, just first tear it apart to the level that's typical for daily tear down, test different sites, see whether you actually have low levels of ATP, whether you have TPC below detectable, and then do a complete disassembly. Find out whether there are some areas deep inside your piece of equipment that are not reached by your typical daily disassembly, and where pathogens or other microbes can persist over time. This tends to be an iterative process because the first time you do it, you're going to find like, wow, we got this one area here that we don't disassemble, but there's a gasket, there's something else there. Maybe there's a dead end that is just not clean and sanitized. So we need to fix it. We need to redesign it. We need to rewrite our SSOP. But once you do this, you start to have data that show that your standard sanitation procedures actually effectively should eliminate Listeria and other pathogens. And then you verify that that SOP is consistently implemented. Think about that. Happy to answer any questions about this if there are any. So take-home message. Number one, and this is very important, Listeria will continue to be an issue and a challenge. My prediction is we're going to see even smaller outbreaks, 2 to 3 cases. And the number of times this could happen. This could happen in fairly safe products, maybe even extremely safe products, but in large productions. Okay, we have a large production. Very rarely do we have a Listeria issue. Our product typically is very safe. But over 10 years, if I make huge production, I might have a case every 5 to 10 years linked to my facility. So far, usually not detected. Or it could be small, medium-sized facilities. Typically, they're not linked to Listeria outbreak because it's reasonably safe. But we make so little product that we're not putting enough product into commerce to cause an outbreak. Those will be detected. Both things are going to be likely to happen. Therefore, continuous improvement is needed, is essential. You can use mock swabathon, similar to what I showed you, to make sure your Listeria control program works. We do this, there are consultants who do this. Make sure your food safety system and practice are validated and verified. We talked about that. Go back into your facility and say, all right, we have always done sanitation a certain way. How do we know it's actually working? Or are we just doing ATP on a small surface and presume that means it's working? Because it doesn't. Make sure you have an SOP for root cause analysis. Have a person that's your root cause analysis lead. Go until it hurts in your root cause analysis. Don't stop after 2 whys. Go for your 5 whys. Okay, so I hope this was useful. We're happy to answer any questions. Sam and Al will join me in that. Back to you, Sam.
Great. Thanks, Martin.